Module 6 review, lesson 6.1. Identify the degree of each monomial. Number 1, 6x squared. The degree is 2 because the exponent is 2. Number 2, the degree is 7, and that's because 3 plus 4 equals 7. Number 3, the degree is 11, and that's because 8 plus 3 equals 11. Number 4, it says rewrite each polynomial in standard form. So what do we got? We got negative 4x cubed plus x squared plus 7x plus 6. All right. The leading coefficient is negative 4, and the degree, let's see, do that different color, degree, the degree is 3, and I got that from right there. And the number of terms, let's see, you got 1, 2, 3, 4 terms. So there are 4 terms. Number 5, let's do number 5. Let's see, we got 2x to the 5th plus 7x to the 4th plus x squared minus 12x minus 3. Leading coefficient. The leading coefficient is 2. The degree is 5, and I got that from right there. And let's see, there are 1, 2, 3, 4, 5 terms. All right, good. Number 6, it says add or subtract your answers in standard form. So we have to add or subtract, we need to combine like terms. So we need a variable with the same exponent. So let's take a look. Number 6, we got 11x cubed. And then next we got 2x squared and minus x squared. That's going to give you plus x squared. And we look a little bit. Let's see, we got negative 2x plus 5x. So that's going to give us plus 3x. And we have 6 and negative 2. So that's going to be plus 4. Number 7. Now we got subtraction. Okay. And there's a couple different ways that you can do it. You can rewrite it, distributing the negative inside there, or you can just do it sort of like we did there. I'm going to go ahead and rewrite it. I've got x squared minus 8 minus 3x cubed, and then that's going to be plus 6x plus 4 minus 9x squared. So now I'm going to look for my largest exponent. That's right here, negative 3x cubed. So negative 3x cubed. And then my next exponent is x squared. And I got x squared here and a minus 9x squared there. So it's going to be minus 8x squared. And let's look for some x's. I got 6x right here. 6x. Any others? Nope. So we got plus 6x, and then let's see, we have a minus 8 and a plus 4, so that's going to be minus 4. Good, good. All right, let's try this next one. What's our largest exponent? We got 5x to the 4th minus 2x to the 4th, so that's going to give us 3x to the 4th. And in 80x cubes, we have a plus x cubed right there. So we got plus x cubed. And let's see, x squared, we got an x squared here and a 9x squared there, so that's going to be plus 10x squared. And we got a 7, and that's all that's left, so we got plus 7. Number 9, again, we've got subtraction again. So I think I'm just going to go ahead and rewrite it, distributing that negative in there. So I got 12x squared plus x minus 6 plus 9x squared minus x to the 7th plus 8x. I'm going to start off by looking for the largest exponent, and that's right here. The largest exponent is negative x to the 7th. And then what's the next one? Squared. So we have 12x squared and 9x squared. I get plus 21x squared. Look for the next one. That would be x. We got one x there, an x here, and an 8x. So that's going to be plus 9x. Anything left? We got a minus 6 here, minus 6. And that's it, minus 6. So we got negative x to the 7th plus 21x squared plus 9x minus 6. Good, let's do this word problem here. An accountant finds that the gross income in thousands of dollars of a small business can be modeled by the polynomial negative 0.3t squared plus 8t plus 198. So I want to go ahead and that looks like important information. I'm going to underline that. Where t is the numbers of years after 2010. So I'm going to kind of circle that. That looks important. The yearly expenses of the business in thousands of dollars can be modeled by the polynomial negative 0.2t squared plus 2t plus 131. So I got my income here. This is my income. My income is right there. And my expenses are right here. So find a polynomial that predicts the net profit. Well, net profit would be income minus expenses. That's how you get your net profit. So the income is going to be negative 0.3t squared plus 8t plus 198 minus, I got negative 0.2t squared plus 2t plus 131. Okay, so I'm going to distribute this negative here, so I'm going to make this a positive, and that makes that a positive, and that will make this here a negative. That's a squared 2t, and that's going to make that a negative minus 131. All right, now I can do it. So I have negative 0.3 plus 0.2. That's going to give me negative 0.1t squared. I have 8t minus 2t. That's going to give plus 6t. 198 minus 131 is going to give me plus 67. So I have negative 0.1 t squared plus 6t plus 67. Now, assuming that the model continues to hold, how much profit can the business expect to make in the year 2016? Well, this is 2010. So if I take 2016 and I subtract 2010 from it, I get 6 years. So the profit of 6 years would be negative 0.1, and that would be 6 squared plus 6 times 6 plus 67. And I can put that in my calculator. Negative 0.1, open parentheses, 6 squared, and then plus 6 times 6, plus 6 times 6, plus 67. And press enter, and we get 99.4. So that equals 99.4. So how much net profit can the business expect? Remember, this was all in thousands of dollars, so this is going to be $99,400. Not too shabby. Good year. Good year. All right, let's take a look at 6.2. Here we're going to multiply polynomials. So we want to find each product. To do that, we're going to distribute, like for number 1 here, we're going to distribute the 4x squared inside that parentheses. So let me, I didn't want the circle tool. I wanted that one there. All right. So 4x squared times 3x squared plus, and then 4x squared times 1. 4 times 3 is 12, x to the 4th. X squared times x squared is x to the 4th. And then 4 times 1, that's just going to be 4x squared. So that's number 1. Number 2, again, I'm going to distribute that negative 9x in there. And I get negative 9x times x squared plus negative 9x times 2x plus negative 9x times 4. Well, negative 9, so negative 9x times x squared is x cubed. And we got minus 9 times 2. 9 times 2 is 18. And then x to the first times x to the first is x squared. Negative 9x times 4, that's going to be minus 36x. Now, when I'm multiplying, x to the first times x squared equals x to the 1 plus 2, which is x cubed. Here, x squared, okay, I had x to the first times x to the first. That's x to the 1 plus 1, or x squared. And that's how we do it. Let's try 3 and 4. And let's see here. Let's try 3 first. I'm going to go ahead and put that like that. Shoot that down there. And then 3. 3. I have negative 6x squared times x cubed plus negative 6x squared times 7x squared plus negative 6x squared times negative 4x plus negative 6x squared times 3. So if I do each one of these, what do I got here? Here I got negative 6 times, negative 6x, and then 2 plus 3 is 5. I got a minus sign here, so minus 6 times 7. That's going to give me 6 times, that's 42. And then x, and 2 plus 2 is 4. I got minus again. Oh, I got negative 6 times negative 6. That's going to be plus 24. X to the first times x would be 2 plus 1. That gives me x cubed. And then negative 6 times 3 is minus 18x squared. So that's number 3. Number 4. Again, I'm going to distribute that x inside there, x cubed in there. So x cubed times negative 4x cubed plus x cubed times 10x squared plus x cubed, and that's going to be times negative 7x plus x cubed times 2. So what do we got? We got negative 4, and then 3 plus 3 is 6, so x to the 6 plus 10x. 3 plus 2 is 5, minus 7, and 3 plus 1 is 4, so x to the 4th, and then plus 2x cubed. Not too bad. Let's try number 5. Number 5. Again, we're going to distribute the negative 5m in there, m to the third, negative 5m to the third times 7n to the fourth, and then negative 5m to the third times negative 2mn to the third, and then minus 5m to the third times 6. So what do we got? Negative 5 times 7 is negative 35. We have m to the third, and then n to the fourth. Now we have negative 5 times negative 2. That's going to be plus 10. M to the third and m to the, so 3 plus 1. See, that's a 1 there. 3 plus 1 is 4. So m to the fourth, n to the third. Since we don't know what m and n are, we can't combine them. So they have to stay separate. So 3 plus 1 is 4, and then so on. Negative 5 times 6 is negative 30 m to the third. Now let's try number 6 here. Number 6. Oh, looky here. So first we got to distribute the x inside there, and then we get to distribute the 2 inside there. Okay, so this one's going to be long. X times y squared plus x times 2y plus x times negative 12 plus, and then we got 2 times y squared, 2 times y squared plus 2 times 2y plus, and then we got 2 times negative 12. So x times y squared is just xy squared. X times 2y plus 2xy. X times negative 12, negative 12x. 2 times y squared is plus 2y squared. And then 2 times 2y is plus 4y. And then 2 times negative 12 is negative 24. Are there any like terms? Xy squared, no more of those. Xy, no more of those. We just got a plain x there. Y squared, no. All right, so that is simplified. 6 is simplified. 7, we're going to do 7, very similar to what we did with 6. Okay. And let's see here. 7. We have distribute the p in there. So you have p times 4p squared plus p times negative p plus p times negative 8q squared plus p times negative q. So that's the p. Let's do the q. Plus q times 4p squared plus q times negative p plus q times negative 8q squared plus q times negative q. All right, now let's do the arithmetic. So what do we got? P times 4p, 4p to the third. P times negative, that's going to be minus p squared. P times, that's going to be minus 8pq squared. Minus pq. So that got those. Over here, q times, that's going to be plus 4p squared q. And this will be minus pq. And that's going to be minus 8q to the third. And minus q squared. Minus q squared. So what do we got? P squared, do we have any? P to the third. P to the third. That's it. So we got 4p to the third. P squared. Do we have any other p squareds? No p squareds. Minus p squared. PQ squared. PQ squared. Nope. Minus 8pq squared. PQ and PQ, so that's minus 2pq. P squared Q, that's it. So plus 4p squared Q and minus 8q to the third minus q squared. So that's for 7. For 8, 2x squared times y squared plus 2x squared times 3x. All right. And now we have xy. So that's plus xy times y squared plus xy times 3x. Now we have negative y minus y times y squared minus y times 3x. All right, now we can do the arithmetic. What do we got? We have 2x squared times y squared. That's going to be 2x squared y squared plus 2 times 3 is 6. X squared, that's going to be x to the third. That's those two. Plus x y to the third. And that's going to be plus 3x squared y minus y to the third minus 3xy. So x squared, y squared. Any more of those? No. X cubed. Any more of those? No. X y to the third. No more of those. X squared y. Nope. Y to the third. Okay. So that is simplified. Number 8 is simplified. And I just checked my notes, and yep, that's it. Number 9, expand each expression. Couple ways to do this. Probably the easiest way is to go ahead and use the binomial expression. So number 9, y to the third. So you're going to have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. There's our coefficients. 1 plus 3 plus 3 plus 1. Not a problem. Let's see here. 3x. We got 3x, and I wanted to do that in a different color. Let's see. So we got 3x, and that's going to be to the third power. 3x to the second power. 3x to the first power. And 3x to the 0 power. Next, we got the -1, so we got -1 to the 0, -1 to the first power, -1 squared, and -1. So let's move these exponents inside the parentheses. Okay, so here we go right here. We got 1 times, and then 3 to the third power is 27, and then x cubed, and that's going to make this just 1. All right. And the second one here, plus, that's going to be 3 times, and then 3 squared is 9, and then x squared, and that's going to be -1. And this one here, well, so we got plus 3, and then 3, and the x to the 1, and then -1 squared is 1. And then this last one, that's going to be plus, let's do this here in purple here. That's going to be 1 times 1 times, well, hold a second. I didn't put the 3 there. And then -1 to the third power is -1. All right. And that was supposed to be done in purple. All right. Now let's see what we got. So 1 times 1 times, that's going to be 27x cubed. 3 times 9, that's going to be plus 27x. And it's minus, oh man, I missed that. Let me just, we got 27x cubed. And that's going to be minus 27x squared. And I didn't put the square, I didn't on that. I don't know what happened to that. And here we're going to have plus 9x, and then minus 1. So that's 9. 10. Well, let's look here. Oh, this is to the 4. So we got to take our line. One more. 1, 4, 6, 4, 1. So that's going to be 1 plus 4 plus 6 plus 4 plus 1. And then we've got x, so we'll just put x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 0. And then we've got -4 here, so let's put -4 to the 0, -4 to the 1st, -4 squared, -4 to the 3rd, and then -4 to the 4th. All right. Now let's do the arithmetic. We got 1 times x to the 4th times, and that's going to be 1, plus we're going to have 4 times x cubed times, and that's going to be -4. -4. And then here, we're going to have plus 6 times x squared times 16. And here, we're going to have plus 4 times x, and then that's going to be times negative 4 times 4 is 16 times 4 is 64. Plus, and then we'll do this one here like this. That's going to be 1. X to the 0 is 1, and that's going to be positive 64 times 4. Oh, yeah, 64. That's going to be 16 for 1. 256. So what do we have here? That's just x to the 4th. 4 times negative 4, that's going to be minus 16x cubed. And then 6 times, that's going to be plus 6 times 16, that's going to be 96x squared. And that's going to be minus 4 times 64, that's going to be 256x plus 256. Big numbers in my head. Let's take a look. X to the 4th minus 16x cubed plus 96 minus 256. There we go. So that's perfect. There's your answer for number 10. Number 10. All right, let's try number 11. Number 11. Yeah, let's see here. Couple ways to do it. Let's see here. What I would like to do is, see, you got this 3 here, right? So 3, open parentheses. And then you got a minus. So what is squared? Well, 1, 1, and then 1, 2, 1. So let's go ahead and use that binomial theorem. You got 1 plus 2 plus 1. All right. And then here we've got a squared, a to the 1st, and then a to the 0. Then you've got negative 4b to the 0, negative 4b squared, and negative 4b, that's squared, and that's to the 1st power. Got a little happy there. And all right, and now let's close that parentheses. So you have 3 times, and let's go ahead and do this. We got 1 times a squared times 1. All right, negative 4b to the 0 power is 1. And then the second one, that's going to be plus 2 times a times, and that's going to be negative 4b. All right. plus 1, and a to the 0 is 1, and negative 4 squared is going to be 16, and then b squared. All right. And that closes it all off. That closes it off. So you got 3 times a squared, and then 2 times, that's going to be minus 8ab plus 16b squared. And then 3 times, that's going to be 3a squared minus 24ab plus 48b squared. 3a squared minus 24ab plus 48b squared. And there's number 11. Number 11. Number 12. Okay, this one here goes to the 3rd, and we already know that's 1, 3, 3, 1. So we've got 5 times 1, and that would be plus 3 plus 3 plus 1. And then that closes. And then what do we got? X squared. So we got x squared to the 3rd power, x squared to the 2nd power, x squared to the 1st power, and x squared to the 0 power. Next, we got negative 2y, and that's the 0 power, negative 2y to the first power, negative 2y squared, and negative 2y to the third power. All right. So we still got this 5 out there. Let's look, 5 right there. Now let's work on these in here. You got 1 times, and then x squared. So x squared to the third power equals x 2 times 3, which is x to the 6. And that's because this says x squared to the third power is x squared times x squared times x squared. Well, if you do it like that, that would be x times 2 plus 2 plus 2, which is x to the 6. Now, I don't want that to confuse you. Just know that when you have a power of a power like this, you multiply them. When you have a power times a power like this, you add them. When you have a power of a power, this is called a power of a power. All right, and this one, that's that one there. And then let's see, like this right here, that's called the product of a power. Okay, product of a power you add, power of a power you multiply. So here we got 1, and then x, that's going to be times x to the 6 times, and then negative 2, that's going to be 1. And then the second one here, that's going to be plus 3, x squared squared, that's going to be x to the 4th, and that's going to be times negative 2y. Here we got plus 3 times x squared to the first power is just x squared. And then negative 2 squared is going to be 4, and then y squared, so 4y squared. And then this last one, plus 1 times, and the x squared 0 power is 1, times, and negative 2 to the third power is going to be negative 8, and then y to the third power. Because that cube goes to both of those inside there. So we have 5 times, and then 1 times 1 is 1 times, that's just x to the 6. And 3 times negative, that's going to be minus 6 x to the 4th y. That's that and that. And then 3 times 4 is going to be plus 12 x squared y squared. And then 1, that's going to be minus 8y to the third. Now that we've got all that, we can distribute the 5 in there. So that's going to be 5x to the 6 minus 30x to the 4th y, 30x to the 4th y, plus 60x squared y squared minus 40 y to the third. So that's number 12. Let's take a look at 13. A biologist has found that the number of branches on a certain rare tree in its first few years of life can be modeled by the polynomial the branches of the tree equals 4y squared plus y. The number of leaves on each branch can be modeled by the polynomial the leaves of the tree, or the leaves of the branch, equals 2y cubed plus 3y squared plus y, where y is the number of years after the tree reaches a height of 6 feet. Write a polynomial describing the total number of leaves on the tree. Okay, to get that, well, we know this says how many leaves are on the branch, and that says how many branches, okay, are on a tree. So we have to multiply the tree branches would be b of y, the number of branches, times the number of leaves on each branch. Okay, so this is going to give you 4y squared plus y times 2y cubed plus 3y squared plus y. So let's distribute the 4y squared in there. 4 times 2 is 8, y to the 5th, 4y, that's going to be plus 12, y to the 4th, 4, and that's going to be plus 4y to the 3rd. Now let's distribute the y in there. Y, that's going to be plus 2y to the 4th plus 3y to the 3rd plus y squared. All right, now let's look and see if we have any that we can combine. We have 8y to the 5th, no more, so 8y to the 5th, y to the 4th, and y to the 4th. So that's going to give us plus 14y to the 4th, y cubed, and that's going plus 7y cubed, and then plus y squared. So that, if you put the 6 in for that, that would give you the number of leaves on the tree. That would give you the number of leaves on the tree during its 6th year. All right, let's look at the binomial theorem, 6-3. Use the binomial theorem to expand each binomial. What you may want to do is go ahead and start you a tree. Start you a tree, okay? Because let's see here. We're going to need one. We got 1, 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. So that's the highest that we go is 5. All right. So let's take a look at it. We have y to the 3rd, so we're going to use this row right here. We got equals 1 plus 3 plus 3 plus 1. And then we've got our x here. So this is going to be x to the 3rd, x squared, x to the 1st, and then x to the 0. Let's see here. Next we have y. So that's going to be y to the 0, y squared, y to the, that's y to the 1st, y squared, and then y to the 3rd. Now we just need to do the arithmetic and do it like we did just a minute ago. What do we got here? X cubed, because y to the 0 equals 1, plus 3x squared y plus 3xy squared plus y to the 3rd. Not a problem. Now number two, we're going to want to use this row right here. Okay, because it's got a 4 and that's the 4th row. So what do we got here? Equals 1 plus 4 plus 6 plus 4 plus 1. We got 2x here, so this is going to be 2x to the 4th. That's going to be 2x to the 3rd. That's going to be 2x to the 1st, and that's going to be 3. That's going to be 2x squared. 2x to the first, and then 2x to the 0. The next one is y. So we're going to have y to the 0, y squared, y to the first, y squared, y to the third, and then y to the fourth. That's a 0. All right. So what do we got here? 2 to the fourth power is what? 16. Let's do a different color. That's going to be 16. There we go. Now we got a different color. 16x to the fourth. Remember, y to the 0 is 1. And then we got plus 2 to the third is 8. 8 times 4 is 32. So we got 32x to the third. Y. Plus 2 squared is 4. 4 times 6 is 24. And that's going to be x squared, y squared. 2 times 4 is 8. So we got plus 8x, y to the third. And then 1, and then 2x to the 0 is 1. So we're going to have just plain y to the fourth. Okay? Let's take a look. 16x to the fourth plus 32x cubed y plus 24 x squared y squared plus 8xy cubed plus y to the fourth. Not a problem. Number 3. Okay, number 3, we're going to use this one up here. Okay, the one with the 3 in it. So this will equal 1 plus 3 plus 3 plus 1. And what do we got here? We got m. So m to the third, m squared, m to the first, m to the 0. Then we have 3n. So we've got 3n to the 0. And then we have 3n to the first. And we have 3n squared. And then we have 3n to the third. Can't see that for the line, can you? Let's see. 3n. Let me see if I can write that down a little bit. 3n to the third. All right. 3n to the 0 is 1. So we are left with this one here is m to the third. And then 3 to the first power is 3. 3 times 3 is 9. So we got plus 9 m squared and n to the first. 3 squared is 9 times 3 is 27. So we got 27 m to the first, n squared. Here, 3 to the third power is plus 27, and m to the 0 is 1, so we just have n to the third. Not too bad, not too bad. Now the fifth. Now it's a party. Now it's a party. So we're going to do this row here. So this equals, and let's see if I can scoot that up a little bit. This equals 1, and then we're going to have plus 5, and then plus 10, plus 10, plus 5, and plus 1. Those are your coefficients. All right. We got p. So we got p to the fifth, p to the fourth, p to the third, p squared, p to the first, and then p to the 0. Q, we got q to the 0, q to the 1, q squared, q to the third, q to the fourth, and then q to the fifth. So let's write this out. This one right here, we've got just p. I wanted to do that in a different color there. We just have p to the fifth power. That takes care of that. Plus 5p to the fourth, q, takes care of that, plus 10p to the third, q squared, plus 10p p squared q to the third, and then plus 5p q to the fourth, plus q to the fifth. And there you go. Easy peasy. All right, let's roll this up here. Now it's time to do a little probability. Probability. Of the new cars in a car dealer's lot, 1 in 6 are white. Today, 4 cars were sold. What is the probability that three of the cars sold were white? Okay, to do this with the binomial distribution, we need to know a few things. One, what is n? Okay, and right here, this is n. That's n. What is p? Well, it says 1 in 6 are p, so that's p, which is 1 over 6. Okay. We're also going to need to know what q is, and q is 1 minus p, or 1 minus 1/6, which would give you 5/6. Okay, now let's answer the question. What is the probability that 3 of the cars sold were white? Well, your 3 here, that is your R. That's what you're looking for. So the probability of R, or 3, is going to equal, and then what do we got? Well, we've got 4. And the formula is the probability of R equals n choose R times p to the R, and then q to the n minus R. All right, so 4 choose 3 times 1/3, and 1/3 to the third power times, I'm sorry, I wrote third, 1/6, and then that's going to be 5/6 to the first power. Okay, now if we go in our calculator, we can go menu 5, excuse me, 6, no, excuse me, 5, and then 3, and then we got 4, comma 3, close parentheses, times, open parentheses, 1, control, divide 6, close parentheses, caret 3, times, and then open parentheses, 5, control, divide 6, close parentheses, caret 1. Press enter, and then if it gives you a fraction, just control, enter, and 0.015. So that's 0.015. Now, what is the probability that at least 2 of the cars sold were white? So this is going to be the probability that R is greater than or equal to 2, at least 2, which is the probability of 2 plus the probability of 3 plus the probability of 4. So you're going to add all of those up. Now, you've already got 3 of 4, so you'd have to do 2 of 4 and 4 of 4. Or if you want, you can use, go to your calculator, menu 5 for distributions, and then go down here and find binomial CDF, and it should be B. All right. Number of trials is 4. Probability of success is 1, control, divide 6. The lower bound is going to be 2, and the upper bound is going to be 4. Press enter, and that gives you 0.1319. So you're going to answer equals 0.13. Okay, that's not too hard. Let's try number 6. At a small college, 1/3 of all students are vegetarians. There are 5 students in line at the cafeteria. You need to ask yourself, what's the important information? 5 here, that's your N. 1/3 here is your P. Okay? All right. Remember, Q is 1 minus P, which in this case would be 2/3. All right. What is the probability that all 5 students are vegetarians? So what is the probability of 5? Well, that's going to be 5, choose 5. And then you're going to have 1/3 to the 5th power, and then 1/3 to the 0 power. Okay, so let's go to our calculator. Menu 5, 3, and we got 5, 5, close parenthesis, make sure I'm doing this. Yeah, that's 5. All right, and then we've got times 1, control, divide, 3, close parentheses, caret 5, times, and then open parentheses, 2, control, divide, 3, close parentheses, caret 0, and press enter. Again, control, enter, and you got 0.004. So that 0.004. So there's a 0.4 chance that all 5 students in the line are vegetarians. What is the probability? What is the probability that just one of the students is a vegetarian? All right, so the probability of 1, okay, that's going to be 5, choose 1, 1/3 to the 1st power, and then 2/3 to, and I put a 1, that should have been 2/3. 2/3 to the 4th power. Okay. All right. So let's try that. Menu 5, 3, 5, 1, close parentheses, times, open parentheses, 1, control, divide, 3, close parentheses, caret 1, times, open parentheses, 2, control, divide, 3, close parentheses, caret 4. Press enter, control, enter, 0.329 or 0.33. So 0.33. All right. Ellen plays 8 hands of a card game with her friends. She has a 1 in 3 chance of winning each hand. What is the probability that she will win exactly half of the hands? So probability of, well, half of 8 is 4. Probability of 4. So we got 8, choose 4, and then 1/3 to the 4th, and then 2/3 to the 4th. All right, let's go to our calculator. Menu 5, 3, and you got 8, 4 times, and then 1, control, divide, 3, close parentheses, caret 4, times, open parentheses, 2, control, divide, 3, caret 4, enter, control, enter, 0.1707 or 0.17, we'll just say 0.17, 0.17. In a lottery, each ticket buyer has a 1 in chance of winning a prize. If Chip buys 10 tickets, what is the probability that he will win at least one prize? Okay, so the probability is going to be R at least 1. Okay, so he could win 9, he could win 10, So probability is R is greater than or equal to 1. So this is going to be the probability of 1 plus the probability of 2 plus the probability of 3 and so on all the way up to 10. Or you could do the complement. That would be 1 minus the probability of 0. Okay, 1 minus the probability. That would get it a lot quicker. Because this other one, that would be probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 and so on and so on. So you could do 1 minus, so that would be 1 minus 10 choose 0. And let's say 1 in 10 chance, so 1/10 to the 0, and then 1/10 to the 10th power. Okay, so let's do that in our calculator. 1 minus menu 5, 3, and we got 10 choose, or 10 choose 0, and then times 1 control divide 10, and that's going to be caret 0 times, well, if it's 1 in 10 chance of 0 of winning, that means it's a 9 in 10 chance of not. Okay? Close parentheses, caret, and then that would be 10. 1, 0. Control, enter. 0.65 equals 0.65. 0.65. So there's a 65 chance that he would win 1 or more. All right. But the odds for the actual lottery are much larger than 1 in 10. Let me go get 4 back. There's 4. And let's see. There we go. Factoring polynomials. Simplify each polynomial if possible and then factor it. Okay. Step 1. Step 1. Find the greatest common factor. So what's the greatest common factor? You got 3, and that leaves you with n squared minus, and 48 divided by 3, that's like 16, right? Okay. Now, are we done? We got to look at it. Are we done? N is a perfect square, isn't it? N squared is a perfect square. 16 is a perfect square. So if you look, this is equals 3, and that's n squared minus 4 squared. So that's a difference of perfect squares. So your answer is going to be 3 times n minus 4 times n plus 4. And let's look at number 2 here. What's the greatest common factor? 3x. And that leaves you with x squared minus 25. Well, that would be 3x, and then you got x squared minus, and that's 5 squared, because 25 is a perfect square of 5. So you have 3x, difference of perfect squares, would be n, or excuse me, I don't know why I wrote n, x minus 5 times x plus 5. All right, let's take a look at number 3. Is there a greatest common factor of 9 and 16? No. But if you look, you got 3m squared, 3m squared minus, and that would be 4 squared. Again, you got a difference of perfect squares. So you have 3m squared minus 4 and 3m squared plus 4. Take a look at 4. I'm seeing a difference of perfect squares. So you got 4r squared minus, and it's 3 squared. So that's going to give you 4r squared minus 3, and then 4r squared plus 3. Look at number 5. We got a greatest common factor here. Let's take the 3 out, and that leaves you n to the 6 minus 4. So you got 3, and then n cubed squared minus, and then 2 squared. So you got 3 times, and then that's going to be n cubed minus 2, and then n cubed plus 2. Now, n is a perfect cube, but 2 is not a perfect cube, so that's as far as you can take that. Let's take a look at 6. You got x cubed squared minus, and then you got 3 squared. The difference of perfect squares, so you got x cubed minus 3 times x cubed plus 3. Look at number 7. What can we take out of there? The greatest common factor is going to be 3b. What does that leave you? That leaves you b to the 6 plus 4b to the 3rd plus 4. Okay, now this is a little bit tougher. We're going to have 3b, and then you have b to the 6 plus, and then 4b. So this is a perfect square, and 4 is a perfect square. So we're going to have b cubed plus 2, and then b cubed plus 2. Okay. Looking at number 8. Okay. I notice that all of these are even, so I know 2 will come out, and that will leave you with 25 b to the 6 plus 60. Ooh, I took a 2 out, so that's 30 v cubed plus 9. 25 is a perfect cube, or perfect square. 9 is a perfect square, so I'm at 2, and then that's going to be 5v to the 3rd plus 3, and then 5v to the 3rd plus 3. How about number 9 there? Number 9. What do we got here? X cubed minus 60. Okay, I'm seeing x cubed minus, and that's going to be 4 cubed. I gave you a thing for that. I said if you had a cubed minus b cubed, that would equal a minus b times a squared plus ab plus b squared. I gave you that algorithm, so that's going to apply here. We're going to have x minus 4 times x squared plus 4x plus 4. Okay, looking over here, I'm seeing x cubed minus, and that's going to be 5 cubed. We're going to do the same thing. We're going to have x minus 5 times x squared plus 5x plus 25. And let's see here. We need to move it up. 11. All right, 11. We got x to the 6. What do we got here? Would this not be x squared cubed minus, and it's 4 cubed. Okay. Well, this is going to be kind of tricky because that's going to give you, that's a difference. Well, let's see here. That's going to give you x squared minus 4, x squared minus 4 times, and then x squared squared, that's x to the 4th, plus 4x squared plus 16. Okay, can that be factored some more? Number 11, I believe it can. Well, let's see. Oh, you know something? Let's do this a different way. Let's do this a different way. Equals 64 is a perfect square, and so this is going to be x cubed squared minus and an 8 squared. Okay, so that's going to give us x cubed minus 8 and then x cubed plus 8. Let me write that over here. X cubed, you can't see that. Well, let's write it right here. X cubed minus 8 times x cubed plus 8. Now, x is a perfect cube and 8 is a perfect cube. X is a perfect cube and 8 is a perfect. This is minus, so that's going to be like we did a minute ago. You're going to add x minus 2 times x squared plus 2x plus 4. Now that's for that one there. For this one here, you're going to have x plus 2, because that's 2 cubed is the same as 8, right? 2 cubed is 8. So x plus 2, and that's going to be x squared minus 2x plus 4. Okay. Number 12. Number 12. Let's take a look at it. Let's take a look at it. Now, let's take it up here first. So this is going to be x cubed squared minus, and that's going to be 1 squared. That's going to give us x cubed minus 1 times x cubed plus 1. Well, this x is perfect cube. 1 is a perfect cube, so that's going to give us x minus 1 times x squared plus x plus 1. And here we're going to have x plus 1 times x squared minus x plus 1. Okay. Number 12. What do we got here? Factor each polynomial. So let's group the first two and then group the second two. What's the greatest common factor in there? That's going to be n squared. So that's going to give us n squared, and we'll have 8n minus 7 left. And then in here, what can we pull out? Plus 7. We got 7, and that's going to leave us with 8n minus 7. So this will give us n squared plus 7 times 8n minus 7. Looking at 14. Looking at 14. Let's do that grouping thing again. We'll group the first two, make that a plus, make that a negative inside there. Negative inside there. All right, what's the greatest common factor in the first one? That's going to give you x squared, and you'll have left 5x minus 6. All right, what's the greatest common factor in here? Let's take out minus 3, and that will leave us 5x minus 6. So we have x squared minus 3, x squared minus 3 times 5x minus 6. Looking at number 15, let's do the grouping thing. We got 4 terms, so we group. That makes that a plus, Negative 21 minus 7. Greatest common factor in the first part, I get 3r squared. What is left? What is left in there? 3r plus 1. And let's look at the second half. Minus 3. Let's pull out a 3, minus 3 out of there. Minus 3. And what does that leave? What does that leave? We can't pull a 3 out of there, can we? We had to pull a 7 out. Let's pull a 7 out. Negative 7 to be exact. Pull out a negative 7, minus 7, and that's going to leave us with 3r plus 1. So our answer is going to be 3r squared minus 7 times 3r plus 1. We can do some grouping over here. Let's do some grouping over here. Group the first two, group the second two, and let's see what comes out of here. What we can take, let's see, equals 25b squared, and what's left in? What's left in? b plus 1. b plus 1. What can we pull out of the back half there? We can pull out a minus 15. What's left in? b plus 1. Now, what do we got? What do we got left? We have 25b squared minus 15, and we have b plus 1. Well, Mr. Carbonell, there's a greatest common factor in there. It sure is. Let's take that 5 out. Let's take the 5 out. So we got the 5, and that leaves us with 5v squared minus 3, and that's going to be times v plus 1. What did I not do? I did not look for a greatest common factor. Number 17. Number 17. What can we take out of there? Let's take a 5 out. 5 out. What does that leave us? What does that leave us? 120 divided by 5. 120, let's see, 0, and then let's see, well, 2, and that leaves 20. That's 24. B to the third plus 21b squared plus 40b plus 3 is 15. 3 35. All right. Now let's group. We'll group the first two and group the second two. What's the greatest common factor in the first two? So we're going to have 5. The greatest common factor of 24 and 21. 24 and 21. 3. So we got 3b squared. 3b squared. And that leaves inside of there 8b plus 7. And then what about in the back half? What's the greatest common factor? 5. And that leaves 8b plus 7. All right. So we have 5 times 3b squared plus 5 times 8b plus 7. Wow, that was a tough one, but y'all did good. Y'all did good. Now, let's look at number 18. What is the greatest common factor? 120, 80, 160. I'm going to go with 8. So I'm going to take an 8 out. Let's see, 8. And that's going to leave, let's see, 8. That's going to be 15x cubed minus 10x squared minus 21x plus 14. Boy, I sure hope I got all that right. I'm going to group the first two, plus, and then group the back half. And then what do I got? The greatest common factor there, that's going to be, let's see, 5x squared. And that's going to leave 3x minus 2. All right. And then here in the back, I'm going to take out minus 7. And that's going to leave 3x minus 2. Okay. So my solution, I'm going to have 8. And then I've got 5x squared minus 7 times 3x minus 2. And there you go. Number 19, a square concert stage in the center of a fairground has an area of 4x squared plus 12x plus 9 feet squared. The dimensions of the stage have the form cx plus d, where c and d are whole numbers. Find an expression for the perimeter of the stage. Okay, remember, let's see here. Let's draw that. Remember a square, and let's see if I can draw a square. That looks to be a square. See if that works. A square, yeah, that's a square. Okay. Square. Okay, so if we remember right, side, because they're all the same. So the formula for a square is side squared. Okay. So if we look at this, 4x squared plus 12x plus 9. 4 is a perfect square and 9 is a perfect square. So the square root of 4 is 2x, and the square root plus 3, and then 2x plus 3. Let's take a look. 2x times 2x is 4x. 2x times 3 is 6x. 3 times 2x is 6x, and 6x is 12x. 3 times 3 is 9. Okay, so we've got it. Okay. The dimensions of the stage have the form cx plus d, all right, where c and d are. Find an expression for, well, the perimeter is 4 times the side. So we're going to have 4 times 2x plus 3, and that's going to equal 8x plus 12. What is the perimeter when x is 2? So the perimeter of 2 would be 8 times 2 plus 12, which is 16 plus 12, which is 28. Not too bad. Not too bad. All right, good. So that's number 4. We're getting there. Dividing polynomials. Divide by using long division. Okay. Divide by using long division. Let's scoot this up a little bit. And we'll get us a little real estate here. I wanted the, not the square, but I wanted that height. There we go. All right. So we've got x minus 3, and we're going to divide x squared minus x minus 6. So x times x, we're going to put x right here. X times x is x squared. X times minus 3 is minus 3x. We're going to subtract that. So those cancel out, and we're -1 minus -3. -1 plus 3 would give you 2x. And let's bring the 6 down, minus 6. So next step, we want to turn x into 2x. So we're going to multiply by 2. 2 times x is 2x. 2 times is minus 6. So, all right. Our answer is going to be x minus 3, which I got right there, times, that's going to be x plus 2 that I got from right there. All right, let's try this one here. We got x minus 5. I need to drop that down a little bit. X minus 5. And we're going to divide 2x cubed minus 10x squared plus x minus 5. All right, so we're going to multiply it by 2x squared. 2x squared times x is 2x cubed. 2x squared times 5 is minus 10x squared. All right, so we're going to subtract that. That cancels out, that cancels, so I'm left with 0. All right, let's bring this x down. So I got x and then minus 5. All right, so we're going to put plus 1. 1 times x is x, 1 minus 5, and that gives us it. So our solution is going to be x minus 5 times 2x squared plus 1. Not too bad, not too bad. And I need a little real estate here to clean that up a little bit. Clean that up. Number 3. So we got x minus 6, and we're going to divide negative 3x squared plus 20x minus 12. So I need to make, that's going to be, let's see, 3x squared, negative 3x squared. So I'm going to negative 3x. Negative 3x times x is negative 3x squared. And that's going to be plus 3 times 6 is 18x. All right, well, if we subtract those cancel out. 20 minus 18, that's going to give you 2x minus 12. If I multiply that by 2, 2 times x is 2x. 2 times negative 6 is negative 12. Subtract those, I get 0. So my solution is going to be x minus 6 times negative 3x plus 2. And let's do another one here. Let's do another one. So we got x plus 3, and we're going to 3x cubed plus 9x squared. We don't have an x in here, so we're going to put plus 0x to hold that spot, minus 14. All right. We 3x squared. 3x squared times x gives you 3x cubed. 3x squared times 3 is plus 9x squared. We subtract those cancel out, we're left with 0. So what do we have left? We just have the negative 14. So our solution is going to be x plus 3 times 3x squared and then minus 14. That's our solution. On the test, you may see it written as x plus 3 times 3x squared plus, minus 3x squared minus, and you might see 14 over x plus 3. You might see it written like that too. All right. And divide by, now it's about to get easy. Now it's going to get easy. All right. Let's do this here. Almost done, folks. Almost done. Remember, you don't have to watch the entire thing. You just need to watch what you need to. All right. So we got 2 And then we got 3, negative 8, and 4. All right, bring the 3 down. 2 times 3 is 6. That gives you negative 2. 2 is negative 4. So your remainder is 0. So you have x minus 2, and started out squared. So this will be 3x, and that will be minus 2. So we have 3x minus 2. Remember, we're dividing an x out, so that makes it from 3x squared to just 3x. Let's try number 6. We've got negative 3 in the box, and we have 5, negative 4, and 12. Bring the 5 down. Negative 3 times 5 is negative 15. That gives you negative 19. That's going to give you a positive something. 3 times 9 is 27. 3, so 2, and then 3, 4, 5. So that's going to give you 57. And add those, and you get 69. Okay, so what is our answer? Well, remember this started out, so that's going to be 5x minus 19 plus 69 over x plus 3. That's the other way you may see it. 5x minus 19 plus 69 over x plus 3. I see it that way. Number 7. Let me clear that off. We'll do number 7 real quick and in a hurry. What do we got? We got 1 in the box, and then that's 9, negative 7, and 3. Bring the 9 down. That gives you 9. That makes that 2. Put a 2 here. That gives you 5. So you got a remainder of 5. This becomes 9x plus 2 plus 5 over x minus 1. All right. And then number 8. What do we got? We got negative 7 in the box. That's negative 6, 5, and negative 10. So we bring negative 6 down. That gives you 42. Negative 7 times negative 6 is 42. And 5 plus 5, that's 47. So that's going to give us negative. That's going to be 49, 4, 28, 3, 29. So negative 3, 3, 9. All right. So we're going to have negative 6x. Well, let's do it the more traditional way. You got x plus 7 times negative 6x plus 47, and then minus 3, 3. I'm not writing too well right there. 3, 3, 9. All right, good. Use synthetic division to evaluate P of x. So we've got, okay. Let me scoot that up a little bit more. And let's see. Getting close to the end, folks. What do we got? We got 3 in the box, and then let's see, we got 4, negative 9, and 2. So bring down to 4, that gives you 12. Negative 9, that's going to give you 3. 3 times 3 is 9, so we get 11. So P of 3 equals 11. All right, we got negative 2 in the box. That's negative 3, 10, negative 4, negative 3. That's going to give you positive 6. That's going to give you 16. It's going to give you negative 32. That's going to give you negative 36. So P of negative 2 is negative 36. Determine whether the given binomial is a factor of p of x. Number 11. Number 11. What do we got? So we got 4 in the box, and then we got 1, 8, negative 48. So let's bring the 1 down. That gives you 4. 8 and 4 is 12. 4 times 12 is negative 40, positive 48. So that gives you 0. So determine, yes, it is. And the factors are x minus 4. And then this would give you x plus 12. And if you multiply those, you'd get that right there. And let's try this next one here. Let's try this next one. All right. And let's see, what do we got? So we got negative 5 in the box, and that's 2, negative 6, negative 1. So bring the 2 down. Negative 5 times 2 is negative 10. It's going to give you negative 16, negative 5. That's going to give you a positive 80. So that gives you 79. You got 79 remainders, so no. X plus 5 is not. All right, let's look at 13. The total number of dollars donated each year to a small charitable organization has followed the trend D of t equals 2x cubed plus 10x squared plus 2000t plus 10,000, where D is the dollars and t is the number of years since 1990. The total number of donors each year has followed the trend t squared plus 1,000. Write an expression describing the average number of dollars per donor. Well, what are we going to have to do here? You're going to have to divide. So you've got t squared plus 1,000. And let me give myself a little more room there. T squared plus 1,000. And well, to find an average of something, okay, so anyway, 2t cubed plus 10t squared plus 2,000t plus 10,000. All right, are we missing any? Nope, we got them all. All right, so what? T squared, so that's going to be 2t, right? 2t times t squared will be 2t to the third. And then 2t times 10,000 or times 1,000 would be plus 2,000t. All right, we got to subtract that. So that's plus 0 here. So these cancel out, and we have 10t squared. Those cancel out, plus 0t plus, and then we got to bring that down, 10,000. Okay, so now we need to multiply it by plus 10. 10 times 2, that's going to be 10t squared plus 10,000. All right, and that's going to give you a 0. So write an expression describing the average number of dollars per donor. That would be 2t plus 10. Okay, there's your expression. Great job on the review, folks. See you tomorrow in class, and have a great evening and good luck on the test.